Alright, we're asked to use factor by grouping for this trinomial. A lot of times when I'm introducing factoring polynomials, I like to have a little bit of a roadmap to follow. I've referred to this a number of times. I'm going to slide the problem over and take a look here. Because something that I have not put on this list, and I don't plan to, is something that we're actually going to have to do here. I looked for GCF and there isn't one. I have 3 terms, but again, the leading coefficient is other than 1, but you have to look way over here to see it. The standard practice is to rearrange your polynomial with descending powers of the terms. So 2x squared, I'm going to slide this out of here now. 2x squared needs to be our first term. Then you have a negative 5x, and finally a positive 2. Okay, that's not on my list of 4 things to follow. Bring that back in. But you might want to expand the list. I try to keep these as simple and basic as possible. Okay. If there's a leading coefficient other than 1, I say you can use the box method or factor by grouping. They have asked us to use factor by grouping, so we'll do that way first. It's considered a bit more sophisticated and less mechanical than the box method, so it's a real good idea to try to learn this. Factor by grouping. You are going to multiply the first term times the last term. That gives you 4. It's a positive 4, note that. And then you list all the factors of 4. 1 times 4, 2 times 2. Now if you get here by multiplying, and again I'm asking you to do a little investigative work. When I say we get here by multiplying, I mean if you already had a factored form of the equation. Let's put that in here. If you already had a factored form of the equation, this positive 2 came either by multiplying positive times positive or negative times negative. This middle term is the result of addition or subtraction. If that's negative, I couldn't have used positives. It had to be negative and a negative. Alright, so both these terms are negative. Get this thing out of here. And I'm actually looking for a sum of negative 5. This will not give me a sum of negative 5, but that will. Alright, for factor by grouping, you put your first term in the first position. You put your last term in the last position. And these middle 2 terms, it actually, I don't think it's going to matter which order we put them in, so we'll see. I have negative 1, and you really have to remember I multiplied 2x squared times 2. That gave me 4x squared, so there's x by each of these. Okay, so it's negative 1x and negative 4x, and it appears that I forgot to indicate this was a plus 2. Okay, once you have it arranged in 4 terms, you can use factor by grouping. Slide this up a little. You focus on the first 2 terms and look for a GCF. That's going to be x. And the common practice is you put the term you're factoring out goes in front of the parentheses. If I factor x out of these first 2 terms, I'll be left with 2x for the first term, and I'll just be left with a minus 1 for the second. Okay, then we turn our attention to the next 2 terms. I can factor out a 2 from each term, but you're going to have to notice something. If I factor out a positive 2 from this, I'll have a negative 2x. If I factor out a positive 2 from here, I'll have a positive 1. And notice that I'm left with a negative 1 in this set of parentheses. I want this set of parentheses that I'm about to fill in to match this set exactly. So I'm going to factor out a negative 2 from each of these terms, and that will give me a binomial that looks identical to the one that I have right here. Alright, if I factor a negative 2 out of negative 4x, I'll be left with a positive 2x. If I factor a negative 2 out of a positive 2, I'll be left with negative 1. And now you basically repeat the process of factoring out the GCF. Here I have 2x minus 1 and 2x minus 1. That's my common factor. That's what I'm going to factor out. And standard practice in math is if you factor something out, we're factoring out 2x minus 1. If you factor something out, you put it in front of the parentheses. So here's the parentheses. If I factor out 2x minus 1 from there, the only thing left is an x. If I factor 2x minus 1 from here, the only thing left is negative 2. So this is the factored form of, let me slide this back, even our original trinomial, but it's better to probably look at it in this form. Alright, you can also use the box method, so I'm going to crank that out real quick. We'll get the exact same result. Alright, I encourage you to use factor by grouping. It's a little more respected than the box method. The box method is considered somewhat mechanical and unsophisticated. Oops. I have to rearrange these so they're in descending order. 2x squared, negative 5x, plus 2. Leading coefficient other than 1. I'll use the trusty box. First term in first box, last term in last box. To figure out these other two, you've got to do a little work. Multiply 2 times 2 gives you 4. List all the factors. 1 times 4, 2 times 2. This is a positive 4. The only way you can get there, and when I say get there, I mean if you had this in factored form, you would get this last term either by positive times, you multiply these two. If they're both positive, you would get a positive. If they're both negative, you would still get a positive. Okay, either of these cases will yield a positive result. But to get a negative in the middle, that's the result of addition or subtraction, you can't be using positives. They must both be negative. So these are negative. Okay, I want to get this guy out of here. That means I'm looking for a sum of negative 5. That means that won't work, but that will. So that's negative 1, negative 4. And this is really an x squared, so there's an x by each term, but I just say remember to put in an x. Now you look for the GCF. Coming out, a 1 is the only common factor. If the negative's almost out, I pull it out. Coming straight up here, you can get a 2x out of each term. Coming straight across, you could get an x out of each term. And straight across, the negatives there, a negative 2. Alright, now I have my binomial factors, 2x minus 1 and x minus 2. Alright, and notice that's the exact same result we got using, excuse me here, if we used factor by grouping, we got the exact same result, 2x minus 1, x minus 2. Okay, either way, you have the factored form of the original equation.